Okay, I'm going to try to take the derivative of log base b of x by the definition. And this is a difficult one. Okay, so if you happen to still be having trouble taking derivatives normally, this would not be a good place to start. Okay, um, so this is not a good beginner question, but it does come up a lot of having to take the derivative, so it is a worthwhile problem, but it's not a good place to begin taking derivatives. So if that happens to be you, I wouldn't start with this one. Anyway, let's see what happens. So by definition, well, here's how I do it. I plug x plus h in where x goes, and then I subtract the original function, right? So automatically, I'm stuck because h is in the argument, and I'm trying to divide it by h. And I'm trying to get rid of this bottom one because I'm going to divide by 0 if I'm not careful. So just writing it by definition has already got me stuck. So how can I fix this? How can I do something with it? My thought is x plus h x. I'm going to have to use log properties. I think if I rewrite this, I might get something else out of it, but we'll see what happens. So I think with log properties, since they're being subtracted, I could say this is x plus h over x. Okay, now the rest is the exact same as it was before. So I'm just going to rewrite this. It's still the limit as h approaches 0. And it's still h in the bottom, but I'm going to rewrite the numerator and see what happens. So far, nothing good has happened. H is still stuck in the argument, so that's kind of a bummer. But I'm wondering what else can be done. I'm in log base b, and I'm wondering what else can be done. Well, I'm wondering, again with log properties, I'm wondering, since this is log base b, this argument here, I'm wondering if we can't rewrite this using the change of base formula. So rewriting this would be 1 over the natural log of b, and then you would have the natural log of x plus h over x, and then the rest hasn't changed at all. So I'm just rewriting the other part of the problem that hasn't changed. Now that's using the change of base formula. So I have this log base b, whatever base we're in, that's where it's at. That's where it's going to stay. Now that doesn't seem to have bought me anything. It doesn't seem like that's all that helpful. I'm looking at this x plus h over x. I could rewrite that as 1 plus h over x. But you ask me, why? Why would you do that? And I'm wondering if I can't play with this a little bit differently if it was rewritten. So I'm happy with the natural log of b at the moment. But now I'm kind of playing with this argument here and seeing what might happen. All right, I'm going to rewrite what we have and what's not changing. So this equals, and the natural log of b isn't going to change. So I'm just going to pull it out of the limit. It's not going to, it's just a constant. So by our limit properties, I can pull that out and just get it out of my way for a moment. Okay, fine. I still have this natural log, though. And we still have the h on the bottom. And I was mentioning that I want to turn it into 1 plus h over x. Okay, remember, h is going to 0. So when h goes to 0, the denominator is tending towards 0 from the left and the right. Over here, h is going to 0. When h goes to 0, let's assume x is not 0. When h goes to 0, this thing goes to 0. And then you have natural log of 1, which is 0. And so this thing is going towards 0 over 0. And if it's 0 over 0, that's an intermediate form, which tells me I need to work on it some more. Okay, so how can I do that? I think what we could do is we could try substitution. And you say, boy, you're doing a lot of substitution to solve this problem. And you would be right. This is a hard problem. Okay, again, this is not a beginner derivative here. I'm going to see if I let u be h over x. So that's going to go in there. I want to see what would happen. Okay, so if that was the case, what would happen? 1 over the natural log of b, the limit as h approaches 0, the natural log of 1 plus u over, so here I'm noticing if I make this u, I need to make this the same thing. So I'm going to make an alteration to what I said. I'm going to change this up. Let's cross that out. Let's call that u goes to 0. And then we would have x u. Okay. Fine. U's going to 0. But that's the same problem we were in before. If u goes to 0, you have 0 over 0. So have I led us down the wrong path? Maybe. But I think I have a plan. Since this is still going over 0, I want to see what would happen if we took the derivative with respect to u. Okay, so using L'Hopital's rule, I want to see what happens if you take the derivative of top and bottom. So d over du, d over du, natural log 1 plus u, x u. Now what's going to happen? If you take the derivative of the natural log of 1 plus u, you're going to get 1 over 1 plus u. Here you'll just get x. So what happens? Natural log of b, the limit as u approaches 0. This is 1 over 1 plus u. This is x. Okay. And if you're okay with it, I'm going to switch this back to h over x. 1 over the natural log of b, 1 divided by 1 plus h over x over x. Whoops, and then this is the limit as h goes to 0. Now, 1 over natural log of b, 1 over, and I forgot it again, the limit as h approaches 0 of x times 1 plus h over x. All right, notice what's going to happen there. I'm not going to forget it this time. H approaches 0 of 1 over the natural log of b, and that's going to be x, and that's going to be h. And see what happens when h goes to 0. You get 1 over x. So finally, after all that, I think we get 1 over the natural log of b times 1 over x. Wow. That is a difficult one, but a worthwhile one, I think. But it's not a good one to start with, so that's what I think it equals. 1 over the natural log of b times 1 over x. But that's pretty cool. I think that's pretty cool. It was the logarithm of base b, and it outputs the natural log of b. And the reason why we did that is it was an algebra thing of how to find that, but we used change of base to do that. So we used a lot of logarithmic properties to do that, but maybe that should be expected because then again, we were dealing with logarithms, so it would make sense we do that. Anyway, I hope that's helpful. If you have any comments or concerns, just let me know.